The recording has started. The date is June 7th, 2018. This is a scheduled lecture period of ITSE 2309 at Collin College. Call your attention to a couple of things. So those of you who are here or listening to the recording later, note this is a screenshot of an earlier screenshot I took. Notice that down here you have two options. One of them is stop the video. If I click that stop video, now this is a screenshot, it does so you can see it. If I click this icon, it turns off my picture as far as you can see. So I'd have to bring it back to full screen. If I click the mute button, what that does, it mutes my microphone such that you can't hear me. You can still, excuse me, such that I can't hear you. If you turn off your microphone, you can still hear me. If you turn off your video, you can still see if I have mine turned on. And okay. Let's see. I wanted to talk tonight about SQL. We should have our SQL installed. Now, the way I always install mine, I go to services. Now, you can put an icon. You can put this as a shortcut on your desktop. It is found over in scrolling all the way to the bottom of Windows 10 down to Windows Administrative Tools. And if you scroll down in there to services, no, there should be here. Windows Accessories, Administrative Tools, I'm in the right place. Here it is, Services, okay. Find the services, and I suggest you make an icon for it so you don't have to look for it. This one, you do have to scroll down. There's no way to make an icon to one of them, down to the SQL server, and it's there in alphabetical order. So SQL Server, SQL Express. Notice that I have set mine to a manual startup. And in manual startup, that means that I have to go start it. Notice it is not running right now. So I have to start my SQL server. Notice I can change the startup type right here. When I double clicked it and this window open, and I can change the startup to automatic, manual, or disabled. I suggest you put it on manual and then start. And it won't take it long to start, and now it has started and everything's fine. The reason we do that is because SQL Server is a fairly large piece of equipment and or piece of software, and it drinks a lot of your resources, so there's no point in having it running if you're not using it. Now that it is running, now my SQL server is running, and now I can start the SQL Server Management Studio. All that's running, all that this Server Management Studio is a graphical user interface. And let's say, remember my password. Doesn't take it very long to connect. This is our graphical user interface over here. It's a little bit like Access in a lot of ways, although I can see a little bit more. The databases, if I drop them, I see my two databases that I've created. Let's see, I can see under the databases, I can see the tables. And we're going to talk about tables today. We have several tables, contact updates, GL accounts, graphical global ledger accounts, invoice archive, invoice line items. We're mainly going to be looking at the invoices, the terms, and the vendors for a little while. These last three are going to be the ones that we are most interested in. If I want to see more about it, I can drop down, I can look at the columns. If I right click it, I can say edit the top 200 rows. And this gives me the data that are in there. So now I can see the data, go in, and actually I can change it. I can add rows here. And guess what? We're not going to do that. We're not going to do anything with that much, but you can see it that way. So this is a full graphical user interface, and we say that SQL Server is Access's big brother. And it truly is. Anything Access has, SQL Server has, but we're going to be working with SQL. So with respect to SQL, this Object Explorer, it is okay to close this if you want to. And you can get back to it by going to View, Object Explorer, and it comes back. Sometimes I close it if I get too much stuff going on the screen. Okay, the first thing I want to point out is New Query. If I click New Query, I get this command line. So this is my command line. And I can type my SQL code into here. Don't forget to save it. I can also run it from here. Instead of that, what I'm going to do, I'm going to say File, Open a file. And I'm going to go to where I know my files are. I say I know where they are. It appears to have hung up somehow here. I'm going to close it. Something went wrong there. So I'm going to go ahead and restart. Back to where I was a minute ago, and let's see, I'm looking for, I had one here called Module 3. Well, what did I do with my file? Textbook files. Well, okay. I attached a file to Canvas that I told you I was going to use. I'm going to slip over to Canvas and get that file. It's in the under the announcements. And let's see, attached, find this guy. So here we have the file, and it's called module3.sql. I'll download him. Save. Now I will go open him. So I went and got that file. Okay. Well, I just saved it. Save link as. Where is he going? Colin? Spring. Oh, putting it in spring 2018. There it is. Okay. Finally got it open. So here is my file that is open. Now this is an SQL file. Let's talk about this guy. I'm going to talk about line 7 first. Line 7 has the word go on it. And I'm pointing out here in a comment, I say go is unique to SQL Server. What go does, it makes everything happen. And SQL Server needs to have this when you create things. So I'm going to create a table here using SQL. And it likes not to have anything else running. So when you execute a go that says, finish all of your work and start this over again. The only place that you need to use this right now is when you create a table. We're going to be creating other stuff later, and we'll use it there, but only when you create a table do we need to have it. So we create the table, we finish creating the table, and then we say go. We create another table, finish creating the table, say go, and then we do other stuff. Okay, so you don't have to say go in between every statement. I just say go before and after a create statement. Let's start with line 1. Line 1 is not SQL either. Line 1 simply says if the object ID dependent is not null, drop table dependent. This is because if I try to create the table and the table already exists, it will give me an error. If I try to drop the table and the table does not exist, then it will give me another error. So I have to have some way to get around that. So I say if object ID, and there's the name of the table. Notice that it is in single quotes. So just make a copy of this, and that this is the syntax that's used. If the object ID dependent is not null, just exactly like that, drop table dependent. In SQL, we will generally use the uppercase. We will generally write in uppercase, except for identifiers that I name. So if I'm making up the name, I write it in a mix of uppercase, lowercase. If it's part of the language, I write it in uppercase. In this case, the if statement does not come from SQL, and we are not going to be using it this semester. You'll learn more about this in the next class if you plug for my fall class, which is ITSE 2347. We'll study this language. So if object ID employee is not null, drop table employee, and this order in which they are dropped is important. I'm going to come back to that in a minute. I believe I haven't turned off your microphones, so if you wish to ask a question, you may turn on your microphone. Just down there where I showed you how to turn it off, you turn it back on the same way. So I have not muted you, I don't think.
I have a question.
Go ahead, Natalie, I believe.
So when we turn in our assignments, are we using the Scratch database that we created?
This one is going to use, I don't have use in here, do I? Just a minute. I forgot something. Thank you for asking that question, Natalie.
No problem.
All good. Database scripts select which database to use. And so in this case, yes, we would. In the normally, as we get rolling here, we're going to be using the AP database. If we're creating our own tables, as we work with creating tables, we're going to use Scratch. So that allows you to create it without cluttering up your accounts payable database. So it's not unusual at all to have 2 or 3 databases and one just used for testing.
Okay, because I was looking at the assignment 3, and in the guided practice, you used one, I think it was DB Cooper, so I wasn't sure if we were supposed to make one like in Warden database or something like that.
Right. You can make the database. The database you use doesn't really matter to me.
Okay.
Except I don't want you using your AP, your accounts payable database, for just creating files. Scratch is just a name I came up with. It's like DB Cooper, Database Cooper. I came up with that just because it's kind of a throwaway name, and we so anything that's in there you can just delete.
Okay.
So if it's in, and so I said, well, I'll just name it Scratch. So this is the first time I've named it Scratch. So you might see other database names. If you do, those are just the Scratch names. The AP_DB is the one that is our official simulating a work environment. So we're going to be a little bit more careful with that, but you don't have to be real careful with it, because if you hose it, all you have to do is run the script again and it comes right back.
Okay, so for the assignment that we're going to be turning in, we should use Scratch.
Yes, yes. Mm-hmm.
Okay, thank you.
Just like this. This is an example.
Okay.
So this file, go ahead and add that to your, go ahead and use my, the other thing it needs to have is my name. Maybe tell me what it is. I'll know. So this is a comment. This is another way to do a comment. This is a single line comment. This only spans one line. This one is a multi-line comment. You've probably seen this before. In SQL, all SQL statements are supposed to end with a semicolon. The SQL Server is not fussy about that, but many of them are, and I am fussy about it. Okay, let's talk about an employee. If I have an employee, if I'm running a database, and let's say I'm HR, I had tickle cough tonight. Goodness. If I'm HR and I have employees, what information do I want to keep about an employee? And I've come up with some ideas. How about an SSN? I certainly want the employee's name. I certainly want the employee's date of birth. I certainly want the employee's salary. I don't know what this is, a number, some kind of I'm just demonstrating a number I might want. I might have his IQ and his shoe size. Now I'm going to step over here to the modules. If you want to work in Notepad, you may. That's a real handy little editor. Since we already have one, since we have an editor in our user interface, you can use that one, or you can use Notepad if you want to. SQL is the native language of database. We are going to try to focus in this class on pure SQL. SQL that is not where everything I'm going to talk about should run in any SQL platform. That won't always be true, but we're going to try to get it that way. So I'm going to try to stay in pure SQL, such that if you pick this up and put it into Oracle, it would run just fine. This is Note. Shut up. Next. And I don't want this one either. Okay, here I'm talking about the So, Natalie, here's this is just a, database. It says change the database name. In other words, the one that you have. This is just. I'm saying whatever it is. This is your Scratch database. Um, Let's see. Let me give you the rules for a database table. A database table essentially has, we call it the first normal form. And a database table has some rules that we will apply to it. The first rule of a database table is that a field only has one value per field. In other words, we do not put we do not put 2 or 3 phone numbers into the same text field. Although you could, that would violate the first rule because now you've got 3 values stuck in there separated by commas. This is not good. Another one would be if you have a name, and I think you saw that I did it there. I just said the employee's name. And well, employees have a first name and a last name. If I'm ever going to want to separate them out, then I should break them out into 2 fields: employee first name, employee last name. That would just be standard practice. So if I ever are going to want to search on the area code, for example, then I need to have that as a separate field. The second rule of database is that a field is accessed by content only, and that means that we do not ever ask for the third record, or we should not ask for the top 10 records, as we are going to see that we can ask for the top 10 records, and our textbook does do that. I'm going to say I don't particularly like that one. Okay, and then and then the last one, of course, says that no 2 records may be the same in all fields. And that brings us to the idea of a primary key. So is there something about that record that is guaranteed to be different? In this case, it's probably the Social Security number of the employee. Everybody has to have one, and it has to be different for everybody. So that's the 2 properties of a primary key. Everybody has to have one, and it has to be unique. What's the best primary key? Obviously here is a Social Security number. Person's name might be unique, but it's just by an accident. Social Security number is unique by design. Okay. If you choose a Social Security number, that is correct. The Social Security, everybody has one. A primary key cannot be null. And we say a field is null when the field has no value. We have a saying in database: nothing gives us lots of trouble. And it's true, nothings give us a lot of trouble, because the problem with null is that I have trouble. I can't search on null. I can't compare null. I can search on null, but I can't compare null. It's kind of like asking, is my car older than, newer than, the same age as your car? If I don't have a car, it doesn't make any sense to ask. If you don't have a car and I don't have a car, are the ages of our car equal? Now, you might think it's so, but it isn't, because null means, equal means is the same thing as, and null means there is nothing here. So these give us a lot of trouble. So all tables must have a primary key, and then we're going to talk about it here. So here is a little create table snippet. Notice that it ends in a semicolon. It is good practice if, I think this is just the way that Canvas is rendering it. It is good practice if you do not have a blank line, a completely blank line, inside of a statement. Outside of it's fine, but inside of a statement you should not have a blank line, but I think that's just the way Canvas is rendering it. So let's talk about text values first. We have 2 ways to, actually we have 4 ways to talk about text, but we'll start with 2. I have 2. I have char fields, C-H-A-R, and this gives me the upper bound, how many characters I can have in it. So in my ESSN, I can have up to 9 characters. If I don't use 9 characters, it fills it out with, it puts leading spaces in front of it. So if I only use 4 characters, it'll have 5 spaces in front of it. So this would be, if you were looking at this from another programming language, it would be like an array of characters. Okay. The name, on the other hand, is varchar. Varchar means variable length characters, 16 in this case. And this one can vary from 0 to 16, depending on how many characters you have. So which one's better? Well, the varchar does not use as much space. So if I have a big character field and I don't use all of it, it doesn't take up all of the room. On the other hand, in computing, nothing is ever free. And there is a cost to that growing it and shrinking it. So my rule of thumb is, if it is a fairly small field, like, oh, I'm going to say under 50 actually, but let's say under 10 for this purpose. I'm going to use a char, and if it's a larger field, I like it to be 50 or 60 characters before it's going to make it worthwhile for me to use a varchar. I'm not going to enforce that number on you. We'll use varchar. You can use varchar for name. In general, char is a fixed length, and name and varchar is a variable length. There is another one, another type that is called, I have it here, I think they mention it in the textbook, is called nchar and nvarchar. Nchar and nvarchar. Char and varchar are ASCII characters. They take up 1 byte each, whereas nchar is what we call a Unicode character. It's a larger character set, and it takes up 16 bits each, or 2 bytes. And the reason we use nchar is to give us support for other character sets besides English. It came as a big shock to lots of us that some of the world doesn't speak English, and that they wanted to have their own character sets. So many times today it's recommended that you go ahead with nchar and nvarchar. You may use either one. Just bear in mind that using nchar takes up more space in your database. If you're only going to have English characters in there, use char and varchar. If you are ever going to, if anyone would come along and put a different alphabet into your database, you're going to have to go to nchar and nvarchar. Okay, let's get to, notice here there's a blank line in there. So instead of just having a completely blank line, I put a dash dash on that line as good programming practice. Okay, here we go. Constraint. A constraint says that the primary key is going to be ESSN. Notice my naming convention here. Not everyone will do this. I'm just going to call your attention to it. This table is employees. What does the table, the table begins with an E. I prepend an E to all of my fields. That's just a style that I have developed over the years, so that as I see this around, as I see ESSN, I know that it belongs to the employees table. If I had a dependence table, I'll have a dependence table in a minute. Dependence table, it would be DSSN for dependence. So that way, when I see the name of the field, I know that it belongs to the employees table. Okay, sets the database. Now, the constraint. Constraint. The constraint has a name. The name of this constraint is employees underscore PK. Anytime you see PK in database, that means primary key. It's a little bit like, oh, I don't know, when you see some abbreviations are known, well-known, PK means primary key. So if I say that, if I put a name on this, and I can make this name long, it's okay if this identifier for the constraint is long. Because if I violate this constraint, I will see, for my reading pleasure, in the error message, I will see this name. Not all databases have really good error messages. They give you very cryptic error messages sometimes and leave you to try to figure out what you did wrong. But at least I will see that error, that constraint name show up. What is the constraint? That ESSN, this field, is the primary key. How could I violate that constraint? What were the two things that we said that a primary key had to have? It could not be null, and it must be unique. If either of those don't hold, the primary key will fail. Pause there for questions. If there are no questions, I will continue. You may stop me anytime. Constraint. This one's a little bit different. Constraint is null ename, and it is a check constraint. Check that ename is not null. In other words, you have to have a name to be in my database. I'll talk a lot more about this later. Now, when we create a table, there is one little syntactic matter that I want to talk about, and it will give you trouble. It does me all the time. The last line of a create table statement does not have a comma. The rest of them are separated by commas. Okay? I don't know why they did that. Seems like they could have just made it take a comma at the end, but no comma on the last line. I'm everlastingly coming in here and adding another line to it and forgetting to go back and put the comma there. Other database products do not accept completely blank lines. I thought I had these numbered. Okay, line 10, you have to have a name. So I can check many things. This is an example of a constraint. Now, you cannot say here, you cannot say does not equal, because equal makes no sense at all when you're talking about null. And thus we have our first SQL script. And let's go back over here and let's take a look at this one. This is the one I'm creating for employee. Notice that I drop the table employee first. I say if I have one, then drop it. Go. Create table employee. ESSN, keeping my naming convention. It is char 9. E-name, varchar 32. E-date of birth, DOB, is a date. I'm going to talk about these. We're going to have a whole section on these times. E-salary is called money. Money is just another way of saying an integer. Sometimes some database products say currency. SQL Server says money. This is just an example of a number. Excuse me. I'm going to come back to a number. This is a floating point, sometimes called real. We don't like these. We don't like floating point. And finally, I don't know why I'm keeping my employees' IQ and shoe size. I'd be worried I'd get them mixed up. But the shoe size is an example of an integer. And so an integer is like 9, 10, 11, 12. This is the constraint, employee primary key. Check that the name is not null. So this one is similar. I'm going to now run this part of the script. I can highlight just the part I want to run. I do not have to run the whole script. And I can just say execute. And I get the message, the command's completed successfully. let me make a mistake. Always kind of wondered, if I say I'm going to make a mistake and then I don't, is that a mistake? I'm going to put the comma on the end of it, and I'm going to run it again. Well, now notice that if I go over to my Explorer and databases and Scratch, and I look at the tables, notice that I have employee now. I don't know why I got invoices in there. It must have been something I was messing with later. I'm going to say okay and delete it. Employee now exists. So if I'm going to take it out, I have to start here and run all the way through. It won't hurt it to run to say drop dependent, even though I don't have one, because it says if I have it, drop it, and then this one's going to drop. So I'm going to make a that should not have worked. I should have gotten an error. I guess this version, I guess 2016. This is 2016. Is allowing you to have a comma there. Don't put a comma there, because if you do, it will die on many of them. I was expecting that one to die. If you're using 2012, it certainly would have, and if you were using Oracle, it would have. Notice that I have don't have any completely empty lines. From the time I start the statement until I finish the statement, no empty lines. Outside of it's fine. But inside of it, we don't want empty lines, and we want to make sure that it ends in a semicolon. Okay, date. There's usually four main things that a database or that a programming language supports. It supports text data or characters. It supports numbers, two kinds of numbers, both integer and floating point. And it supports, let's see, text data, integers, floating point, and date. So that's getting real common. So here we have text. In database, we have two kinds of text. We have dates. That's enough for now. Actually, we have several kinds of dates. Just date will be fine. Currency, if I say money, that basically is just a fancy integer, because it's not going to keep your currency in. You're not going to be paid $10.33 an hour. You're going to be paid 1,033 cents. It's not going to. It's going to push that decimal out of it and store it in pennies, which isn't entirely true. But this one is a number, numeric. If I say numeric, this says allocates 9 digits, 2 of which are on the right-hand side of the decimal. So this is a 9-digit number, and 2 of these 9 are to the right of the decimal point. Basically, anytime I fix that decimal point, it turns into an integer. Questions at this point? This one is a floating point, also known as real. You can use either. I believe float is the one that we're supposed to be using now, but the database will accept the term real. We're going to use float, I think. I don't like floating point numbers because they suffer from an inaccuracy. So if I can, you've heard of them, for example, what is it called? I always use the movie Office Space, but a lot of you probably haven't seen Office Space. Has anyone seen Office Space? Okay, well, they had a little scam in there where their computer was dropping off a small piece of the number at the end of every transaction. And that's very true. That's what happens, because if consider 1/3. Well, what is 1/3 as a decimal? Well, it's 0.33333333. But when can I ever stop? I can't stop. So but finally I'm going to run out of memory, I'm going to run out of breath, or I'm going to run out of interest in saying 3 any longer. And whenever I quit, I have introduced a small error into this. With an integer, you don't get that, but with floating point, you do. Okay, so that's just one of the facts of life. We do not like these guys. We do almost anything to avoid having a float. Sometimes I'm stuck with a float. If I have to calculate a interest compounded continuously, I'm going to have a irrational number in there. Anything to do with a circle, I'm going to have pi in there. So I have to have them. And finally, integer is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. It is also the negative numbers, -1, -2, and so on. No comma. Are we cool? Okay, let me show you some things that we do not do. I'm going to comment this one out. You will see people will do this. Okay, this is called an inline constraint. And it works. It works. You heard it from me. That will make ESSN the primary key. But the constraint is not named. So if I violate that primary key, I'm going to see a very cryptic error message. So while this can be done, it is suggested, no, don't do it that way. We are going to name all of our constraints. Okay, I can also put it here. Which is the same problem. And okay. Now, the dependent. In other words, I'm about to bring in the idea of the foreign key. Oh, here, by the way, here I do create the primary key that way just to show you doing it that way once. It is, in my opinion, poor practice. If you want to do it when you get on your own, then do it. Tell me about a dependent. Dependent. How many dependents can an employee have? Anybody care to chime in?
Can you hear me?
I can hear you.
Okay.
How many dependents can an employee have?
It can be any number.
Any number, yes. Well, it has to be, it can't be negative, I don't suppose, but it could have 0, it could have 1, he could have 5. We don't know, okay? So basically, an employee has 0 or more dependents. And this is what we call a 1. I think I have it over here. Employees, how many dependents? 0 or more. This demonstrates a one-to-many relationship. Big word here, one-to-many relationship. You're going to hear that one a lot in this class. One employee has 0 or more dependents. So many means 0 or more. And that's shown this way. This is the way we would see it in our graphical user interface, and I'll show it to you. And so what happens here, the primary key of the one side, is copied over into the many side. I keep the same name. It must keep the same type. So if it's a char 9 in the dependence table, it must be a char 9 in the employees table. Okay, I always keep the same name, but it is not, well, if I can here. It is not critical that it be named The same. I always keep it named the same. Now, look at my naming convention. I'm in the D table, dependents D. What's this? DSSN. Which table does that belong to? Which table does the name belong to? Dependents table. Now, this is just my convention. This is something that I have added to SQL. This is not required, and you will see most people won't do this, but I'm suggesting it as a good idea when you can. And now all of a sudden you find one that does not conform. That one is special. This one takes me to the other table. So when the primary key of the one side gets copied over to the many side, it becomes what we call a foreign key. And thus the constraint. Okay, the primary key constraint here, I have done this as an inline primary key, inline constraint, and I'm flagging it as poor practice, but I want to focus on this constraint. That's the one right now. Constraint, EMP, DEP, FK, FK foreign key. Foreign key, ESSN. Which one am I talking about here? I'm talking about this one. A foreign key, ESSN. References, employee, ESSN. This one is the primary key of the parent table. And we say this is the child, and this is the parent. Pause for questions.
Yeah, if we didn't have the references, what would happen?
I did not get that. I hear you speaking, but I did not get that.
And that constraint, where it says employee, foreign key,
Yes.
underneath that it says references.
Yes.
So if we didn't have that reference keyword,
Yes, it wouldn't work. Question was, is this whole line required? SQL, excuse me. SQL does not care about lines. For example, I could write this just as well like that. So this is essentially one line. I could put this whole create table on one line and it would run just fine. There is no particular breaking of the of it. It doesn't care about things like indenting, but the reader does care, because if you don't format it, it gets tricky. So it gets tricky to understand. So what I do is when I have a long line like this, I will many times break it and tab to show that this is all part of the same line, to show the reader that. I didn't have to. I could have left it, just let it run on. Now, what are the requirements of a foreign key? Foreign key, it says that if I have a foreign key, if I have a value for this field, then that value must appear in the employee table, i.e. no bogus parents. Am I making sense? No invalid parents. Do I have, in the foreign key, this field right here, the ESSN of the dependent table, can that be null?
no.
Okay. Byman says no, but okay. I kind of drew you into that one. It can be. And if it is null, we say we have an orphan. You do not have to have a parent. But if you do have a parent, the parent must be a valid parent in the employees table. Now, I can constrain this field against null in the same way that I did at right here. I can add a constraint to the dependent table. Constraint, I have to give it a name. Check that ESSN is not null. Now it can't be null.
Okay.
If I have one, then he has to be in this table. So which one do I have to put in first? I have to put the employee field in first. So the employee, when I add records to the table, the employee has to be done first. Now, let's go back to dropping these tables. When I drop the table, the foreign key has to be dropped first. Makes sense. Because if I dropped the employee table, then all of my fields, all of my records in the dependent table would become invalid. So I have to drop the child table first. Then I can drop the parent table. Notice that they are dropped in reverse order of their creation, or created in reverse order of their drop, whichever. Questions there?
Now, if in the employees table, ESSN is not null, then how can it be null in the dependent table? How can it be empty in dependent table?
Okay, because they are two different fields that have the same name. This field is a field of the dependent table. So just by putting it here like this, there is no relationship yet between this one on line 20 and this one on line 41.
But the next line, you are connecting them together.
Next line, I conflate them, yes. Now they say that if you have one of these, then you must have a matching record here. But it doesn't say you have to have one. Okay? Yes, it's constrained up here against null because it's a primary key. Questions? Basically, I'm trying to do enough of creating tables to get us started, because I want to get into SQL, but it doesn't make any sense to start selecting from tables unless you have tables. Well, that's probably enough. Actually, there's a lot more than that, but I want to leave us something to do when we get there later. Okay, insert. Insert into employee. So insert and then the field list. The field list can be, the table has to exist. The field list can happen in any order. So I don't have to do this. I usually do it in the order in which I created them, but I don't have to. In the values part of it, the values will be matched with that. The first value goes to the first field. Doesn't matter which one it is. The second value goes into the second field. The third value, by the way, this is the default format for a date. We're going to see later that you can format it any way you like. Salary is 100. The number, this one has 2 decimal points. If I don't give it 2 decimal points, they default to 0. This one is a floating point, and the shoe size. I guess he's just got small feet. I don't know. I just made up some numbers here. So if I were to run this, I get 1 row affected. And if I were to go over to my Object Explorer, and you may go to your Object Explorer, edit top 200 rows, and I will see this first. There's my first record that I inserted. Oh, Fred's in there. I'll call him Fred Littlefeet. And then this one is the next record to be inserted. By the way, if I were to put a record in here, it would also go in, but this isn't a class about using the graphical user interface. It's a class about using SQL. So this is the way we're going to do it in SQL. If I say put data into the table, I mean put it in using SQL, not just put data in there. It is also legal to do this. Insert into employee. There's one field list. And values, notice I have 2 or 3 of the values all separated by commas and ending. So I can have 100 of these. I don't really care one way or the other about 1, 2, 3, 4. Notice that this one is 1, 2, 3, 4. If I tried to insert another 1, 2, 3, 4, so if I tried to execute this again, I'm going to try. Bingo, look what happened. I see, for my reading pleasure, the name of the constraint. This one is giving me some pretty good information. They won't all do that. Lots of them are very, very cryptic. Violation of primary key constraint. I've just been ticketed by the database police. So here's a couple more going. You can either do it this way. By the way, copy and paste is your friend. It does. I just usually, I don't find it to be any more difficult to copy and paste this than I do to do these, because this is what I have to write each time. Either way you want to do it is fine. Just note the syntax of it. We still have the same first line. If it gets too long, break it and tab it over. Same on all of them. And notice they all share the same birth date, but that's fine. Okay, now I'm ready to insert some dependents. DSSN, DName, ESSN. So let's see, Jill is a dependent of whom? 1, 2, 3, 4, 1, 2, 3, 5. So Jill is Fred 2's dependent. So where this one matches this one has to be unique. Jill can only have one parent, but Fred 2 may have more than one. Insert into dependent. This one, Annie, this is orphan Annie. She is an orphan. Does not have a parent. Insert into dependent. This one is bogus because there is no dependent that has 9999. So my choices are 1, 2, 3, 4, 1, 2, 3, 5, or 1, 2, 3, 6. If I try to put anything else in there, it's going to kick it out. This is the idea of delete. Delete from dependent, where SSN, and this is update. Mostly what I want to do here is just get down to the inserts, and this should now run. If I don't have anything selected and I just hit execute, I see my messages. I should see all successes down here. I'm going to let you to figure out. So I will respond to questions on inserts. I realize I've hit them kind of quickly. Been online about an hour now, so I'm going to take a short break and take any questions. Let's see. Let's try to insert Bogus Bob. If I highlight him, he'll still run. When I try to execute him, conflicted with the foreign key constraint. So I get a message for my reading pleasure. Let me review. We're going to use the Scratch database on this one. I don't really care what you name it. Doesn't matter. The reason I like it being Scratch_DB is that when you send me the file, I can just run it against my database and it should run just fine. So if you're using something different than this, then I have to change it. But you know, hey, life is tough. If the object ID, if the table exists, and this is how I say if it exists, then get rid of it, else do nothing. Just go ahead and create. So this is an if condition. This is not an SQL statement, by the way, and this is something we're going to learn about later, actually in the next class, the next course in the fall. We write in this programming language. Then we have a go. Anytime we have a create, we bracket the statement with goes. It doesn't always enforce that. Sometimes you can get away without it. Sometimes you can't. It just depends on the mood it's in. So bracket it with goes. Here's the create table. We have a primary key, and we have character data. We have dates. We have currency or money. We have numbers and integers and floating points. Main one is the char and the varchar right now. We have constraints. This is a named constraint that creates the primary key, a named constraint that creates a not null, no comma at the end. This table has to be created first. Why? Because it's the parent. Then I create the dependent, which has the foreign key. The primary key has to be created first. I have to insert my values into the parent first, then I can insert my children. As I insert the children, if I have a parent, then that parent must appear in the table. In this case, Annie, little orphan Annie here, does not have a parent. That's okay. I could have just left this space blank. It is better practice to put an explicit null in there. But if I had just left it blank, it would have worked. I think it's putting a little red mark on it. I'm curious if it's going to work. Nope, doesn't like that. So don't get too much. If sometimes this thing will just twitch out and you will get you'll get red lines everywhere, and sometimes it just puts them there and I don't know why. What else have I not? Oh, I wanted to show you how to turn on your line numbers. Okay, so you might get out a pencil and take notes here. Let me see if I can do it correctly. I'm going to turn on and off the line numbers, these guys. It is handy to have them on. Okay, let me see if I can remember how to do this. There's several steps involved. So you might want to jot this down or type it into a notepad or something. I go to Tools. Options. Text editor. And with text editor, I'm going to open the drop down. All languages. Tools, options, text editor, drop him down, all languages. And one of your options there is line numbers. The rest of it is up to you. I don't typically do word wrap. I take care of that myself. So if you turn on the line numbers, if I turn them off, I say, okay. Notice my line numbers all went away. But I like line numbers. Do that one more time. Tools, options, text editor. Drop him down. All languages. And I believe it's general on that, but this one. Click line numbers. Okay, that's about an hour. We started at 6. I'm not going to go much. I won't go over an hour. That's about my attention span. We're going to have 2 hours a week, I guess. If we need more, I can give us more. But I think I'll end there for tonight, or end the lecture there for tonight. I'm going to take a short break, and I'm going to pause the recording, and that will be the end of the Okay, in a lab now, and some people have departed, but I'm going to go ahead and make a recording out of this. Byman is asking me about the format of a table, and notice that on line, for example, line 37 here has a create table statement on it, 47 through 35. This is an example of what I consider to be good formatting of the table. Notice that I indent one tab at the beginning. So I have my create table, then I open my parentheses, and I close the parentheses directly under the open parentheses. I think that is good format. Does it have to be that way? No. Could it be this way? Yes, but I won't like it as well. So it's easy to find. So I want to format it such that it's easy to read, easy to find. And I tend to be fussy about format, or I say that I'm fussy about format. And that means that if you are trying to format it, if I see some effort that you're putting into formatting it, I might make some suggestions, but I'm not going to take any points off. I mean, you're working, trying to develop your coding style. A lot of the things that you do in the C programming language, so you mentioned indexing into an array. I assume you've programmed then?
Yes. Yes.
Okay, a lot of the formatting that you use in other programming language will carry over here. What makes a program readable format in C or Java is also makes a nice readable SQL code for the most part. Some stuff in SQL takes a format of its own, and some doesn't. SQL tends to be long and wordy and verbose. That's okay compared to C, where what you could say in just one or two characters in C, you have to write a whole book in SQL. But if you're paying attention to it. One other thing I wanted to point out, since saying it on the recording here, is that I've got two modules due on the 11th. Now the 11th is the suggested due date. That's when I'm going to grade them. Well, I'll grade them whenever I get them. But if you don't understand something and you need to get in touch with me over the weekend or something, don't worry too much about the 11th if you're on top of it, meaning that you're working it and you're aware that it's due. If it's the next day, that's fine with me. The only time I'm going to have a problem is when you get way behind and then throw all of your assignments at me on the last day. That I will not be happy.
Okay.
But I said that my due dates are soft, and that means that you don't have to worry about. Let's say you have a really busy day at work that Monday, and you just can't get to it. Hey, I don't even need to hear about it.
Okay. You wanted all those files, script files in text format, not the zip.
Yes, it'd be an SQL. So if we just say file save, that's going to save it in the right format. It's text. You could do it in Notepad.
That's what you want upload.
Yes. Just the SQL file. So it's going to have it'll have your name in it.
Okay.
It'll have use database, and then it'll do what I ask you to do. You may, let's see, one of them, module 3 wants you to create tables, and module 4 does the inserts. You may put all of that in one file if you want to, but I would like for you please to do 2 submissions, because it doesn't show me that you've turned in until you submit a file.
Okay. No, my question was, you did not want any zip file.
No zip files, please. That puts an extra step in it for me.
Okay. Okay.
They're not that big.
No, that's what I want to make sure.
Okay.
One last thing. You said,
Byman, you're breaking up just a little bit.
Actually, I just got a new, maybe it's a cheap microphone.
Can you set your volume down just a little bit?
Okay.
Try that.
Better?
A little bit. It's breaking up a little bit.
Okay. I'll have to see where the actual mouth of the microphone is, and I'll try to keep it close to my mouth. If you,
Try backing off of it a little bit. Try setting it down on the table.
Oh.
Give us a test.
when you said table,
Okay. I always this headset that I have is this headset only costs $10 or $15 as I recall, and it gives me a very good sound. It's not stereo, so it's not a music headset, but it's a very good communication headset.
I'll find a better one next time.
Yeah. I'll write down the numbers on this one as a suggestion. You can get these on Amazon, and
Okay.
it's not very sensitive. I don't pick up a lot of breath noise or anything like that on it. I'm sorry. Go ahead with your question, though.
Okay. My last question was, can you see me? Because
Yeah.
okay, I see myself at the corner of the screen.
Mm-hmm.
You said something to turn it off, and I couldn't turn it off.
Let me bring that up. Okay, down at the bottom corner of your screen, do you have this?
We have a mute.
Let's see. Up on the top of your screen, you have a way to go into the full screen, and when you start, there down at the bottom, there'll be a way to stop the video. Yeah, alternatively, you could just point your camera at the ceiling, but there's no, there you go, you got it there. You just turned it off.
Yes, okay, now I found it. All right. Thank you very much. You have a good evening.
Okay.
And we'll meet you next Tuesday again, right?
Okay, I'll save the recording here. Hello, Julie.
Sorry for coming in late. I had to work late today.
No problem at all. The recordings is available. I mean, that's why I make the recording.
Okay. I guess you were just talking about Module 3 SQL or something?
Yeah, I've assigned Module 3 and 4. And Module 3 is creating tables.
Okay.
Module 4 is inserting data. I talked today about creating tables, the syntax of the create table. There, I sent an announcement out that has this file on it.
Okay.
And it's attached. I forgot to put the use scratch DB in there.
Okay.
And I'm gonna yell at you if you forget it. So here's creating a table.
Okay.
Constraint, primary key. All this stuff is mentioned also in the textbook.
Good.
I do
Just,
notice.
whoa, hang on. Only one person can talk at a time.
Okay.
Go ahead, Julie, please.
Oh, I do notice you got the social security number is the key. I guess I remember several years ago at my work, they really spent a lot of time replacing those social security numbers with something else as a primary key. I guess, is that what you mean by poor practice?
No, I don't. It is poor practice to put the primary key in line like this instead of as a named constraint. Now, the Social Security number, I agree, is considered confidential today. We cannot use your Social Security number where it could be exposed, so this gives us the college-wide ID. But I have to have something that is unique. So if I don't have the excuse me, the Social Security number to use, I have to come up with something else. And so there we get like college-wide ID or employee number or something. I just simply say SSN because it's not a real person's SSN. So the poor practice is this way of doing it, of doing a primary key, as opposed to this way.
Okay.
Okay.
Okay, I guess the constraint is where you can have like specify you cannot have null or something stuff like that.
Yes, here's one where you're specifying not null.
Mm-hmm.
I can also specify that it begins with a vowel, or I can specify lots of things about it. We're going to talk more about this. The objective of this particular assignment is just to get us started into the create table. It doesn't make a whole lot of sense to start using tables until you understand how they are created.
Right.
So I do this part of it, just enough of it to get us going.
Okay, I see. When I do like some Microsoft Access stuff at work, we cover like things like normalization a lot. Is that going to be covered like now or maybe later?
It will not be covered until more or less the end of the class. There is a module on normalization, and we're going to be talking about the first normal, second normal, third normal forms. I've talked about first normal form, which there's 3 rules to the first normal form that says that a field only has one value, meaning I don't put the first name and the last name in the same field. A field is accessed by content only, not by, I'll never say give me the 3rd row. And
Right.
excuse me. And then there are no duplicates, which implies the existence of the primary key.
Right.
So those 3 rules are first normal form, if it matches that. And
Okay.
then we're going to talk about the second normal form, and we're going to get to about, you'll see that down there about module 12 or 13, normalization.
Okay.
Last question for me.
Go ahead, Byman.
Okay, anything we do in terms of lab work, it should be done on the Scratch DB. Is this correct?
It will be done on the Scratch DB if we are practicing creating tables. I will tell you when we go into SQL, I think in module 5, then we will switch over to the AP. The AP is simulating our production database.
Okay.
So we don't want to trash that. So the Scratch database is where we can practice creating tables, dropping tables, and then in AP we're not going to do that. But then if we make a mistake and mess up our AP database, all we have to do is run the script again.
Okay. And probably the AP will be used to create reports and stuff like that.
Yes, the AP simulates our production database.
Okay. All right. Thank you very much.
Surely.
I'm logging on.
Okay.
I don't have any questions.
Well, that's okay. I'm going to stay online for a little while. And I'm probably going to take off the headset and let's see. Oh, Julie, I went over how to turn the line number on. Do you see my line numbers?
Yes.
Okay, let me show you how to turn these on and off. Well, turn them on because you'll probably want them on. You might want to get out a pencil and paper or something to take notes here, or your notepad or whatever. I go to Tools.
Are you in Notepad++?
No, I'm just saying in any I'm in SQL Server.
Oh, okay.
This is my management studio. So here I can execute my code and I watch it run.
Okay.
So if I want to see my line numbers, because let's say I make a mistake. I never make mistakes, but there's a mistake. And so if I try to execute this, I get my message. It says at line 32, I have a problem. Well, what if I didn't have those line numbers?
Okay, I see.
And yours probably doesn't unless you've turned them on. So I'm going to show you how to turn them on.
Okay.
Tools.
Okay.
Drop down to Options.
Okay.
Options, I'm going to select Text Editor.
Okay.
And Text Editor, I'm going to, this has a drop down, it says more options under it. Under the Text Editor, I'm going to select all languages.
Okay.
And this is general, it's the default, so all languages general. And right there about halfway down is line numbers. So if I
Okay.
click that, then I get my line numbers.
Okay.
So I've got to go about 3 or 4 ways down. It took me a long time to find that.
Okay. Thanks. Just out of curiosity, your goal in the command, the goal command, is it like commit in Oracle?
Similar, very similar to a commit in Oracle. It's it's more of a execution of the script, and so when you create something, you have to. I think of it as a commit. Now we have a commit work in SQL2, in SQL Server, and it works like it does in Oracle. The Go says make everything before this happen. So if I'm creating something, then it needs to have. Excuse me a minute. When I create, let me close this. I'm creating the table. When I say create table, and in general, when I say create anything, it needs to have a go before it and a go after it, even though sometimes it will let you get away without it. It's kind of tricky that way. So we're going to put the go. I put this where, go is unique to SQL Server. It begins a new script. So it's a little bit different than commit, but it's kind of like commit. Think of it like a commit at the script level.
Yeah, because I have seen some Oracle SQL, and I don't remember seeing Go there.
I put that note there that Go is unique to SQL Server, but we're going to do some things that are unique. Here's another one that's on line 5. If the object ID is not null, drop table, that is unique to SQL Server. Now, Oracle has something like that. It's just the syntax of it is slightly different.
Yeah, I think that the if doesn't go first in Oracle or something like that.
Well, the if does. I think you have a if then, THEN, in Oracle. I don't remember that. That comes from a different language, and that's where you start seeing a lot of differences. In the fall, I'm going to be teaching a class called ITSE 2347, and that is teaching that language.
Which language?
In this case, it is called Transaction SQL. So it's a language that is built around SQL. All of the platforms have it. In Oracle, you call it PL/SQL.
Oh, yeah, I remember now. Okay.
Mm-hmm.
Yeah, I've seen that course somewhere.
Yeah, we have that in SQL Server also.
What does PL stand for, though?
It's kind of like asking, what does SQL stand for? I assume it means programming language or possibly procedural language.
Oh, probably procedural. Yeah, that's not makes sense.
Well, it's just its name is PLSQL. It's just those letters. It's like asking, what does C stand for? No.
Now the C# too, right?
I'm aware of that.
Yeah.
Okay.
Okay. So if, like, let's say at work I have a bunch of Access databases, and eventually I want to migrate to a SQL Server, so I guess theoretically I can move them to SQL Server and still keep the Access front end?
You are correct, and that's one of the things that we're going to do in the next class.
Oh, good.
Mm-hmm. I'm going to talk a lot about using Access as a front end.
Oh, okay. Cool.
Yeah, you just push your. It's fairly easy. Migrating between Access and SQL Server is easier than Access to Oracle.
Okay. And I guess you can theoretically use SharePoint too, but I don't have SharePoint at work.
I'm not a SharePoint user, so I would have to defer that until I had more time to study it.
Oh. Okay, cool. It looks like are you going to upload the video soon so I can catch up what I missed?
As soon as I As soon as I hang up here, I will start the upload.
Okay, all right. Thank you so very much.
It's about a 20-minute process to upload.
Okay, thank you.
Are we
Uh,
done then?
yeah, thank you.
Okay, I'm going to start upload.